Section 4.4, page 4. So we're going to go ahead and complete an example. I don't know why it says step B. It should be step A through G. And obviously you can see down below we've got all those answer boxes we're trying to fill in. So we're given a particular function, and for our convenience, the first derivative, which was a little complicated, and the second derivative are given to us, right? Otherwise, we would have had to take a product rule that also involved a chain rule. First thing we always want to find is the domain. And I do not have a fraction and I do not have a log, but I do have a radical. So since it has no number in the index, it is an even root, and I need to make sure the interior portion of my radical is greater or equal to 0. So setting it, basically thinking of it as equal to 0, adding the x squared to the right side, taking plus or minus the square root of both sides, I get that x has to be less than or equal to positive and negative square root, which means x is sandwiched in between those, and my domain is only from negative square root of 2 to positive square root of 2. In our case, the graph is already provided. So for my domain, it can equal 0, so I have square brackets to indicate the ends. Now I need to find the x and y intercepts. The x-intercept, maybe even the more complicated one, is to start by letting the function equal 0. And because the function is a product, I set each term equal to 0. So x can equal 0, and squaring both sides and basically setting the inside equal to 0, which is plus or minus square root of 2. Notice I don't need to find the y value, the coordinates, because we started by setting y equal to 0. So I can jump over to my x coordinates using the 3 x values with 0 as their y value. The y-intercept is easier to find. We just let x equal 0 and plug 0 in wherever x was. And since 0 times the square root of 2 is 0, we get a y-intercept of 0, 0, which that'll always happen. If 0, 0 is one of your points, both an x and a y coordinate. Next, we're checking for symmetry. So remember, we take the input and put a negative x wherever the variable was in the function. Negative x by itself cannot be simplified, but squaring a negative makes it positive, and so that minus a positive x squared stays the same. In this case, because it's just a product in between them, I can think of this question as having parentheses in front, and therefore I do have negative the output. This means I have odd symmetry, or it could be worded symmetry about the origin. Either answer would be fine here. Next, we're looking for horizontal and vertical asymptotes. The horizontal asymptote is when the limit goes to infinity or negative infinity, but our domain was only to negative square root of 2 and positive square root of 2. So we're not looking at the infinities, so there is no horizontal asymptotes. The vertical asymptote is when the function has been simplified and then checking for a denominator of 0, but we don't have a denominator in the function. We have a denominator in the derivatives, but not in the function itself, so that's why we also said there was no vertical or horizontal asymptotes. Now we want to find intervals of increase and decrease, which immediately lend us to the local maxes and mins. Remember, to find intervals of increase and decrease, we start by taking the derivative, which was given to us in this case, and setting it equal to 0. That's when the numerator is 0. 2 doesn't have a variable. 1 plus x would give us negative x. 1 minus x would give us a positive x. And when does the derivative not exist? When the denominator is 0, which we've already solved for twice now, and we know that this is the endpoints of our graph. So instead of going from negative infinity to positive infinity, we go from our interval, which is our domain, and take our 2 critical points in numeric order on our number line to give us 3 intervals in between those points. Now I'm going to go to the first derivative and plug a point from inside the interval. I'll need a decimal in the first interval of -1 to 1, but the whole number 0 is in the middle interval, and I'm back to choosing 1.1. You could have chosen, 1 point something else. Maybe just enter the square root of 2 into the calculator to make sure that you're not going beyond that. But it's actually not that bad to do the math. -1.1, well, there's nowhere to put it in the 2, so it stays positive. It's slightly bigger, but it's -1.1. So slightly bigger than 1 means I'm going to end up with a negative. And here I'm subtracting a negative, so it's like adding. And in the denominator, I'm squaring it, and it's still less than 2, so I'll have a positive. So all of this will result in a negative value, which means this region is decreasing. And I could even jump over here and put that interval in decreasing. 0 is super easy. There is nowhere to put it with the 2, so it's positive. This is going to stay positive. Even with subtraction, I've got a positive. And I really just have the square root of 2, which is positive. So not needing the value, I can see that my middle interval is increasing, which is way down here. And the last one, again, putting the positive 1.1, positive, but it's bigger than 1. So I'm going to have a negative, and I'll still have a positive. So my last interval was decreasing. If I go from decreasing to increasing, from down to up, I have a minimum at -1. I didn't know the y value yet. And if I went from increasing to decreasing, I had a maximum at +1. But to finish those off, I'd have to go back to the original function. I'm going to squeeze out here. So I was putting this -1 all the way up here to get a -1 output, and +1 all the way in the original to get that +1 output. Then I'm asked to discuss the concavity and the inflection points. So I come to part G, inflection points, concave up, concave down. Now I need the second derivative, which was given to me. I want to know really when the second derivative is 0, which is only when the numerator is 0. So I can set this equal to 0. And when I set square root of 2 minus 3 equal to 0, I could add the 3 over. I said square root, but squared. Take the square root, but I got values outside of my domain, so they don't help. We don't technically need to know when the denominator is 0. So taking my one critical number, it's not technically called a critical number, it's my inflection point, I'm going to break up my graph between my domain, right? So I have negative square root of 2 to 0 and 0 to square root of 2. Pick a point in that region, and I'm plugging it into the second derivative. -1 will give me a negative in the first piece. Even though -1 is squared, it's smaller than 3. So when I subtract, I'll still have a negative. And in this case, because it's smaller, I'm going to have a positive. So I have a positive second derivative at -1. This whole region is concave up, and it's the negative square root of 2 to 0 region. And then we've got the reverse, not always the reverse, but in this case it is, when I plug +1 into this second derivative. So I have a concave down region. And we'd found that x equals 0 is our, our inflection point. And we've already said that 0, 0 is on the graph. So I kind of knew that's what's going on. So now what I need to do is take all of this information to create this graph. It's already given, so it's a little deceiving, but here's how I would go about it. I start by taking the x and y intercepts. So I've got my 0, 0, my negative square root of 2, 0, and my positive square root of 2, 0, and well, 0, 0 again. So that doesn't really help me. Next, I'm going to move over to my local max and mins. Because I could see I had a y value of -1, and my domain was square root of 2 and negative square root of 2, I went ahead and spread this graph out. But I'm going to graph my local max, knowing I have this shape coming out of it, and -1, 1, my local min, knowing I have this shape coming out of it. at that point, I really have enough to kind of connect everything. Notice my first coordinate could be spun around to be a mirror image of my third coordinate. But I do have other pieces of information to help me. Like it's decreasing from negative infinity to negative 1, and again from 1 to square root of 2. I don't think I said that right a second ago. I know that my graph is increasing from negative 1 to positive 1, and sure enough, here it is. So hopefully that gives you everything to get that rough sketch of this graph.